a little bit less busy than the last one. Okay? Now, if you want to do it through transformations, you guys who like transformations, not too many transformations here, you would have to decide what that 1/4 tells you to do in terms of a transformation and what the subtract 1 on the end. I think the subtract 1 on the end is easier. That's a vertical shift down 1. Does anyone recall, if you were going to do it through transformations, what effect does that 1/4 have on the graph? The 1/4 is not stuck out front, it's inside. Who has an idea what that effect would be with that 1/4? Joan? A horizontal shrink, and by a factor of, I think I gave you a handout way back, by a factor of what to make that happen? 4. You do a reciprocal, I think it's 1 over, I think I used a C on that handout way back. 1 over C, and C in this case is 1/4, so 1 over 1/4 turns into a 4. You have to go through and multiply all the x coordinates by 4 on your parent graph. And then vertically shift down 1. And you have it. I would prefer, since we're talking about bounding, I'm going to do mine about bounding. You guys like to bound this argument? Now, I just finished it up. I erased the board. Can anyone tell me what do we accept as the bounds of the one cycle that I'm wholly responsible for the tan graph? G, and out to what? Beautiful. Negative pi over 2 out to a positive pi over 2. She's exactly right. I'm going to use that and bound this, what she gave me, like this. It's not rust anymore. And there it is bounded. Just like Gia just gave to me. We go back and look at the parent graph that we did today for tangent. That's what we accepted as the bounds from beginning to end. Now I got to solve for x. Easily done. Just multiply everything by 4. I'm going to show it like this. Just go through and multiply everything by 4. You get something unusual here, negative 2 pi. That's then, in the middle there, the 4's canceled, gives you an x. Now on the other side, of course, 2 pi. And those are my bounds. Arena, this may not be that bad then. You guys agree with those bounds?
Yes.
Okay. Now, remind you, Gia, you remind me twice, so I want you to redraw it. On that parent graph or tangent, it started at negative pi over 2, went over to positive pi over 2. How many points were caught in between? Just, look at that, just 1, not 3 this time. It was a little bit easier, just 1. Okay, now let me set that up. Thank you, Gia. This looks like. Like I said, the feeling is going to be much, much easier than that last one.
And let's just take the center of this,
I mean, the center?
like between the -2 pi.
I know what you're saying. Okay, negative 2 pi, guys, out here. I want you to mark it for me. 2 pi, right here. Now, Gia is telling me, Professor, there's only 1 point on the parent graph caught between the beginning and the ending. Where do you think it is here?
Same as
0. Is it 0? You see, like midpoint? And then Gia tell me, and tell the class, beautiful responses, what was happening on the ends on my parent tan graph at negative pi over 2 then and positive pi over 2? Oh, it's at that vertical asymptotes. Absolutely. Here we go. The professor has a vertical asymptote at negative 2 pi. Vertical asymptote at positive 2 pi. And Rena, did they have anything out front for me to be worried about? No. Perhaps not going to be upside down or something like that happened before the break. All I need to worry about is what? It's going to be vertically shifted down 1. Now I would suggest, this is me, that you go ahead and shift down 1. Now this is not a horizontal asymptote, it's just showing the shift. ahead and put that on there just to be ready for it. Okay, I'm doing like this.
Maybe two.
That's not horizontal azimuth, I'm gonna show the shift down to -1. Now, Gia. Whew, class. What's going on? What's the graph gonna look like? Should resemble its parent. And please remind me, was the parent graph between -5/2 and +5/2 doing something like this? This one should be doing the same thing,
Yes.
except,
First
except,
experiment
is it
you
gonna pass through that point there?
Yes.
Do this. You guys saying the asymptotic professors are saying that now it's gonna go through like that. And up like that, yes or no?
Yes. Do we need to check in?
Ah, gotcha. Oh, you're good, you are good. Will you guys accept that? I think the parent graph went through 0. This one has been vertically shifted down 1. So something like that. I'll accept that. Now, I can draw more cycles if I wish, but that's good enough for me, I've got it. Guys, based on this one cycle, let's get some information out of the way. Domain, oh, I gotta be careful here. X cannot be, oh boy, I've got some clever students in here. I've got an asymptote at -2 pi, I've got one at 2 pi, and I know there are many more. I need a formula that may tell me where those vertical asymptotes are located, so my domain is gonna be X cannot be equal to those values.
2 pi k.
Wow, hang on now. 2 pi k, and of course k again is gonna be a nice integer. Okay, but test it. If I replace k by 0, I get 0. Was there an asymptote at 0? Was there an asymptote at 0? Here's 0. Did I draw an asymptote at 0? Oops, confusing.
2 pi plus 2k.
Oh, listen to that. Hang on. I'm gonna change it on me. What are you gonna say? X cannot be, what'd you tell me?
2 pi
2 pi?
plus pi k.
I was right. It works, we're good. Try 0 again. I put a 0 in there, of course, in his formula, second term drops out, gives me 2 pi. Was there sure enough an asymptote at 2 pi? I got to test further. If I replace k by, I put 0, let's try -1. If I put a -1 in there, I get 2 pi minus pi,
Just,
which is pi.
no, it's not.
Do you think there's an asymptote at pi?
No.
This one's tougher.
Pi k over 2.
Oh, we're guessing now.
That'll be.
But you know what, it may work. And what you had in mind again? I know.
5 plus.
5 plus,
5k over 2.
pi plus pi over 2k. Like this?
Something like that.
Okay, we'll try it. Okay, it works. Replace k by 0, I get pi.
Over.
Was there an asymptote at pi?
No.
Nope. Oh, this graph is easily done, but the period, the domain itself is a little difficult to come up with. You want to have an idea? We'll test it, then I'll show you what I would do to find maybe, okay, what might be. Yes?
Would it be 4 pi k minus 2 pi?
Well, hang on now. X cannot be 4 pi k
Minus 2 pi?
minus 2 pi. If that works, we will accept it. Let's replace by 0. Replace your k by 0, that makes that first term drop out. And you're left with -2 pi. Was there an asymptote at -2 pi?
Yes.
Check. Let's replace k by 1, all integers. I put a 1 in there, the first term becomes 4 pi. Subtract 2 pi, which is 2 pi. Was there an asymptote at 2 pi? Oh, we may have something here. Okay, I put a 0 in there, put a 1 in there, I'm gonna put a 2 in there. I put a 2 in there, this becomes 8 pi, subtract 2 pi, that's 6 pi. Do you think I'm guaranteed by the time I go over to 6 pi, there'll be an asymptote of 6 pi?
I think it-
Yeah, why? What was the period of this graph? Was it 4 pi?
Yes.
When you say period is 4 pi, we haven't found the period yet. But is the period 4 pi?
Yes.
So if I add 4 pi to this asymptote here, it tells us it's an asymptote of what, 6 pi? The formula's working. How'd you come up with that?
I was just thinking, cause, the period is 4 pi, but then I was thinking it's kind of like if it were shifted to the left by 2, so I was like,
Wow,
minus
wow. So that's why you said subtract 2 pi
2. Yeah,
on the, wow.
so you can, I guess also do
That's
plus
the
2
thing,
pi.
that's the first time I think I've ever seen a student give you that. And it looks like it's working. Okay? Now, if you're sitting there saying, Professor, my mind doesn't work like that. I used to get aggravated in classes when my classmates saw something I didn't see it. Randy, you didn't see that? You missed out on the test, Randy? Gee, we all got that. You missed it? Down, hurts. Then all of a sudden, take the next test, and I was the one who got the one right. And I got to smile. You guys didn't get that? It's obvious. There's the answer. No, it's not obvious. This is nice of it, nice. If you need a little plan, a little strategy here, let's do this. Boy, this shit's gonna work. Is there a distance of 4 pi between the two I have? Is there a distance of 4 pi? 2 pi subtract the negative 2 pi, is that 4 pi? So there's a distance of 4 pi between those asymptotes consistently, is that true? So I can use that 4 pi, you use the 4 pi, in fact, in your formula. The period's been used. Okay, we'll do this. I'll probably end up with the same answer you did. I'm gonna start with one of the asymptotes. You may start with this one, as a student did, or you can start with this one. And then show, here's another way to express it, x cannot be, let me try the other one. That's asymptote of 2 pi, but if you add to it 4 pi k, where k is an element of the integers, that should also work. So decide on which asymptote you want to work with. You work with negative 2 pi plus 4 pi k, and it worked. Or you could work with this one, also it'll work. Well, guys, this should work if I replace k by 0, k by 1. I think, I hope it works. You think it does? You want it purple? Should work. Tell me where the asymptotes are. Okay, I like that. We'll take it. Now, I'm gonna erase this. Range. Thank goodness a range is easily seen as all real numbers. Domain range. Period, my goodness, we already said it's 4 pi. Amplitude, none on this graph. There's no highest point. So domain, range, period, out of the way. We've got the characteristics out of the way. Guys, any concern on the graph itself? So Philip, if I say graph one cycle of the tan graph, you say, Professor, on the test, please ask me to graph a tan. Don't ask me to graph sine or cosine. Those are the ones that have 3 points missing in between. Tan and cotan are a little bit better behaved. Done. Arena, did I ask, was there anything else about this particular graph, or just said sketch? It says sketch, right? We're done. Okay. Geez. What's the last one?
H of x equals 2 cosecant parentheses p over 4.
Whoa, whoa, whoa. 3 over 4?
P over 4. P over 4.
Pi over 4.
Pi.
Okay.
Minus x plus 4.
Plus what?
4.
Oh. 4. Mr. Park, did you guys have to go into this much detail in calculus? Or were the functions a little bit better behaved? They were nasty like this? They were better behaved? Was it a little bit easier, or did your instructors say, no matter what, they give you something like this?
I think it was more easier.
Easier than calculus? Than this one?
Yeah.
don't graph it, that's just a cosecant graph. I graphed cosecant, did I graph cosecant today or last time? I did with the sine graph, right? You graphed it, so you guys can refer to that, forgot. I'm gonna do, this, guys, I'm gonna bound it. But first, I am gonna put this in order. Now watch carefully, you'll see the reason why I chose this from the last example. Let's rearrange it, let's take out the negative. So, if I ask, or if you want to do transformations, some of my students are good at transformations, they don't mind. That means you have to vertically stretch by 2. This is a reflection across the y-axis, a horizontal shift to the right, pi over 4, and then a vertical shift up 4. You have all those different colors going on to finally get the graph. Is that true? No, we don't have the time for that. We're going to bound it. So guys, we'll bound this right here, but, gee, I'm gonna clean it up a little further before I bound it. I think we identified earlier that cosecant is an odd function. I think secant and cosine are the only 2 even that we discussed. The other 4 are odd. Anyone tell me, what might I do? I know even's the best. Even says you are allowed to drop that negative sign. It's even, that's cosine secant. If it's odd though, you can't drop it. Anyone tell me what you can do? Yes?
Could you move it in front of the negative?
Yes, you can move it in front. Look at this. Like that. And I think the definition for odd, remind me guys, was it this? Was that the definition we saw earlier today for an odd function, the definition? So am I allowed to, as Ms. Kim Jr. just lift that negative sign up front? Now, that's only for odd functions, but at least it's gone, it's out front now. So guys, we'll think of this now as looking like this, negative 2 cosecant. Now left hand side there is this, which is gonna be better to work with. Still gonna be a messy graph. Okay, here goes. Everyone with me? Now why do I like even, the cosine of the secant? I love even, because you get to drop this completely out. And then start your graphic. Odd, you gotta move it up front. Here we go, guys. Oh, by the way, can anyone tell me, suppose that were a negative sign to begin with? Suppose I had placed the negative sign in front of that 2 in the original function and still had to do this bit. What would happen?
Become positive.
It turns into a positive. You still keep that negative sign out front for odd, and for a negative out front to begin with, it's gonna turn it into a positive. I just bound it. Here we go, we're gonna bound this, be very careful. Now cosecant, can someone remind me from last week, how did we bound the 2 branches of the cosecant graph? 0 out to 2 pi. Okay, 0, less than this, less than 2 pi. There it is bounded. Solve for x. Oh, this is going to be much easier. At least at this point, add pi over 4, pi over 4, pi over 4, and we'll end up with pi over 4 is less than, these cancel, thank goodness, x, less than, common denominator, guys, help me, is that 9 pi over 4? I think, is it?
Yes,
And those are my bounds. We'll start pi over 4 initially. We'll stop at 9 pi over 4. Now, does anyone remember how many intervening points were there caught between? Gia says for tangent only 1. We did tangent. How many? Oh, 3. 3. We gotta find 3, so I'm gonna set you up. The period for this graph, let's take the ending of the cycle, subtract the beginning. It's gonna give me 8 pi over 4. That's not too bad. The period is 2 pi. And then, since I'm going to give you, or we have to come up with 3 intervening points, what should I do next that we did earlier on the graphs? Do we divide by 4? 4 quadrants for the spacing? 4 quadrants. 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 4 quadr readers and this, professor, it's getting involved here. So 2 pi divided by 4. John, here comes what you were talking about. There's pi over 2. Is that true? Don't make a mistake. So we're going to space by pi over 2, and then graph this. So here goes, guys. Bear with me. Chapter 5 is closing down. Gee, I'm bringing some more of these markers. We're going to start at pi over 4. And go out to 9 pi over 4. I better leave lots of space here. And we're going to space by pi over 2. There's going to be a little awkward. Spacing by pi over 2, I need a common denominator. Okay, guys, can I write this spacing as maybe 2 pi over 4? Because the others are in terms of 4. I just add 2 pi over 4. PK, could I call this maybe 3 pi over 4? 5 pi over 4? 7 pi over 4? And finally, 9 pi over 4. I think we have everything we need, don't we? I think. Philip, hang on. At least we got that much done. There's a lot, tons of partial credit in here. Geez, period spacing. Now I gotta worry about, and keep in mind, guys, this is all done. You don't have to worry about this any longer. That's done. All you need to worry about is that and that. So can you tell me what should I do on the grid? Because I'm concerned about the 4 on the end and the 2. What should I do? Should I vertically shift up 4? Am I going to shift up 4 eventually? Okay. Okay, I'm going to show it like this. My axis is now up here. That's the vertical shift up 4. I'm going to do it like this, not the word on the asymptote. Just a reference. Okay, here we go. That's done. Now, how do we rewrite this over like this? Now it's supposed to be stretched by 2, right? And upside down. Was there an X on there? I think I've got me out here. I'm doing cosecant. Where there's an asymptotes on cosecant? Anyone tell me on the parent graph, initially, the first point, was there an asymptote at the first point or not for cosecant?
Yes.
Oh, there was?
Why?
I'm just asking, was there an asymptote at the very beginning on the parent graph? If there was, there should be an asymptote here for me at 5 and 4. Was there on the parent graph? So, we'll do it. You guys mess me up or you don't mess up. And if that's true, there's another one here. And another one here. Got that. Woo! Jeez. Got the asymptotes. Now, upside down, reflected through the x-axis, and stretched by 2. Oh my goodness, help me out. If I go 2 further from 4, am I up at 6? Is that stretched by 2? Yes or no? So basically, you're going to mark it there, and if I stretch down, will I eventually end up at 2 down here? Is that what the vertical stretch means by 2 there? Up to 6, down to a 2. Anyone tell me, based on what you know, the cosecant graph looks like? It looks something like this, I think. Isn't it? Something like that? Was it something like that? Okay. So what is happening, oh boy, guys, I've got 2 branches. Undoubtedly, one branch is in here somewhere. You guys have to tell me where it is. And the other branch is over here. What do you think, where is it? I have not used this point yet.
gonna be 4.
3 pi, what, tell me.
At 3 pi over 4 and 2, there's gonna be like a downward parabolic shape.
Okay, and tell me, where is it?
At 3 pi over 4, 2.
Up to, right here?
Yeah,
And then you, hold on, then you say it's gonna be upside down.
yeah.
Hang on. And follow those asymptotes, something like this. Whoa. Now, where do you think the other piece is?
7 pi over 4, 6.
Oh, this
It's
is
gonna
that.
be facing upwards.
This, that, it's coming
Or, I
up here
mean-
to 6, and it's going upward. Oh, boy, these should look more symmetric than mine are. Joe? June? When you send out those copies, I hope yours are better than mine, they should be symmetric. Okay, guys, would you accept though, do you think this one's opening down, and this one's opening up? Is it true? Based on, what's happening here with my parent graph and so forth, I think we're right. The student's right. Oh, wow. Okay, let me list the characteristics, and I got a question for you as I leave chapter 5. I'm leaving. Domain. If we accept what you see, tell me the domain, X cannot be, and give me something, guys,
Pi K.
just pi k? I got pi before, and I see 4s.
5 over 4 plus pi K.
Whoa, I know. I know what's right. That works. I'm good. Let's try 0. If I put a 0 in here, the second term drops out, you end up with pi 4, perfect. Put a 1 in there, end up with pi k on the end, plus pi over 4, common denominator 4, what's pi over 4? Pi over 4. Is that true? You try one more. Put a 2 in there, you get 2 pi, plus pi over 4, common denominator of 4. I think
9
9 pi over 4? He's correct. He's correct. Now, that's my domain. Range on this one's a little strange, guys, the up and down. What would you describe this as?
From negative infinity to
Up to 2?
and from 6 to pi.
Oh, union, and what, 6 I heard? Through infinity. Wow. What a way to end graph. Okay, domain, range, I will tell you there is no amplitude to worry about. Period, be careful. The cycle ends at 9 pi over 4. So let's subtract from that, where did it start? It started at pi over 4. That's a good way to find the period. This is 8 pi over 4, period of 2 pi. But everything should repeat every 2 pi. Whoa! Domain, range, period. Guys, am I leaving anything out? No. Now, can someone tell me? This is almost like a question like you'd be accepting the final exam. Just go out home, get your A, relax. Here's the question. Does my graph, and I think we have the graph here, does it have x-intercepts?
Yes.
I'd like to know at least what one of them is.
You can set y equals to 0.
Oh, wait, hang on. That's where we find x-intercept. Hang on. What's my time here? Absolutely, you will go back to your function, now you can go back to the simplified version we did here and say, professor said this equals 0. I think we had to do this, don't let me mess up. This, geez, inside here was this. Plus 4. I think we had that.
So cosecant.
He's correct, says, that's where you find the x-intercept, set the y equals 0. Now, if you attempt to solve it, what would you do first in an attempt to solve it?
take out 4 and divide by.
Move the 4 over, hang on. Absolutely. Absolutely, 100%. Then divide by
Minus.
-2. Get this. Oh, my goodness.
Yeah, no.
Hang on. Is that true, guys? So far, so good? Now, if only I knew, maybe you guys know, at what angle or angles on the unit circle, if it worked on the unit circle, is cosecant 1 over y equal to 2? And you should be able to tell me what it is.
It's 1/2, it means 30 degrees.
Go to it again.
30 degrees.
30 degrees. Wow. Pi over 6. What, pi over 6 on the unit circle was for coordinates, pi over 6, please tell me, was it this for pi over 6?
Yes.
And cosecant should be what? 1 over y. And at 30 degrees, pi over 6, y is 1/2. So 1 over that, which turns into cosecant. 1 over 1/2, does that turn into 2? Nice. Nice, that means now you know that this right here represents, or could be set equal to, look at this, pi over 6. Now, that brilliant thinking. Give me another angle that you circle that would also work the same as this, besides pi over 6.
60 degrees, pi over 3.
Not 60.
Oh,
Another one that may work besides pi, shall we get?
330.
No. You give me the pi over 6, which I love, but there's another one right there on the unit circle that, if you put 1 over the y, you get 2 again, besides pi over 6. 5 pi over 6. So you may have to consider, wait, Professor, you're getting carried away, Professor. You may have to consider, makes me some work, I have to leave this chapter. I love what was coming to me. You may also have to consider this could be also represented as 5 pi over 6. And then solve each one of those. If I solve the first one for x, let's see what happens. Move that pi over 4 over, combine with a common denominator of, I guess, 12. Now I've got 2 plus 3, is that 5 pi over 12 or not? I did it quickly. Jeez. Hang on. 5 pi over 12. PK. We think maybe, hang on, that maybe this right here is 5 pi over 12. Now it looks like the grid says it should fall between these two.
It is.
Okay, and I know in terms of 12, this is what, 3 pi over 12? Just renaming. And this is what, 9 pi over 12? Is that true, guys?
Yes.
So does that 5 pi over 12 fall between these? And we're saying it's right there. Nice. Nice. We just found the x-intercept. Now, could I find, I think there was another x-intercept here. I bet, Joe, June, here, yeah. I bet what June gave me, I bet when you consider the 5 pi over 6, we do it quickly. Move that over. What a class. Darn. Common denominator of 12, guys, help me out here. 3 plus 10, 13? Is it 13?
Yes, yes.
Pi over 12, we think, with her help, that maybe that PK, that's the other x-intercept. Now, location, if it is, it should fall between this and this. And I think, guys, in terms of 12, this is what, 9 pi over 12? 9 pi over 12. And this is what, 15? Pi over 12, I'm messing my graph up here, 15 pi over 12. Does that 13 pi over 12 fall between those two? Bill, are there other x-intercepts on this graph besides the two I found?
On this one,
Yeah, on this one cycle, no. But if I should say, list all of them, aren't there some more, if I draw more cycles, more x-intercepts coming up down here? And I just asked for the two here on the principal graph. Jeez. Whew. Now suppose you have not seen me do that, or asked my student to help me, both my students to help me. Suppose you guys had not, and all of a sudden I asked for the x-intercepts on this, and you said, what, Professor? You're asking me to find that point there? We do it. Make sense? If you guys can step back and look at it, I think we're done. Finished. Guys, I'm leaving it. Are we okay? Yes, go ahead.
If we wanted, could we write the x-intercepts kind of like we do for the asymptotes? Where we would do like something pi over 4.
Oh, absolutely.
plus-
Oh, beautiful. Absolutely. You say, wait, Professor, you picked up an x-intercept here, you picked up an x-intercept here. Now, you're gonna come up with like a formula with a pi k that will pick up all of them. You could. That's it. Guys, anything else on this? I hope we have no errors because I'm thinking this. I think it looks good. You guys think it looks good? I think it looks beautiful, so, okay. Before I do leave it, I see one question, Gina, yeah, Gina.
So we know that the cosecant is more than your sine.
It is,
More than y.
yes,
Can we take what we know y to be equal to and solve that?
you could. You may reflect back to the sine graph and use it to graph these. Yeah, absolutely. Okay, one little thing here, guys, I love this. Let me do a quick check. Guys, let me choose, here we go. I will choose 7 pi before, like I did before the break. And we'll do some algebra here. I'm gonna just randomly select 7 pi before, take it back to the original function, put it in. And I had better get an answer, the graph says the answer is 6. That's 7 pi before. I will test 7 pi before. If I don't get 6, this graph's wrong. Here goes, guys. Back in the original, I think this was 2 cosecant. In the original pi before. Subtract, I'm trying 7 pi over 4. Randomly just put in there. Close that up. Plus 4, I hope that's not copied down correctly. H as 7 pi over 4. Okay, guys, crunch this out. Watch for mistakes I can make. Inside here, these two put together, think this, they have the same denominator. What's that, negative 6 pi over 4? Is it negative 6 pi over 4? And I can reduce it down, better yet, to what? Negative 3 pi over 2. Yes or no? Okay. I'm doing cosecant. Cosecant's an odd function. I see a negative sign. What can I do with that negative sign on this cosecant odd function? I can't just drop it. What can I do with it? Move it out to the front. Can I? So we end up with -2 because it's odd. Cosecant, now that negative sign's gone there. I got this, plus 4. If I do not get 6, we're going to close down class, I'm going home. If I don't get 6. -2. Now, can anyone tell me on the unit circle, at 3 pi over 2, what was the ordered pair to begin with? Was it 0, -1 at 3 pi over 2? I'm doing cosecant on it. Cosecant is what? 1 over y. So it's 1 over a -1, which is what? -1 plus 4. We're not going home. We're not dismissing early. Is that 6? The graph says it should be. That's true. Not too much of a graph. That applies fine. much in chapter 6, I think, you told me 6:1 and 6:2, maybe on the back? Okay. We're gonna introduce you to it. Okay, this is brilliant class. Please tell me. Hang on now. You just had a test. That's Friday. Would this function, there's a graph of it, this function here, I think it was a tan. Would this function have, if I wish to find it, an inverse? You guys had inverses on your last test. Would this, based on what you know about inverse, would this function, staring at its graph, have an inverse if I wish to find its inverse? Does it exist? Does it pass the horizontal line test? If I pass the horizontal line anywhere I wish, I just get what? 1 point of intersection? Beautiful. Did I erase it? Oh, I didn't erase it. Does this one, which has 2 branches, does it pass the horizontal line test? No. So would I expect an inverse for cosecant? Not at this point. No. It would not pass the horizontal line test. The only time I have here, this time here, we do one thing that works for me. You guys must be tired after all this. This is the start of chapter 6. I'm just briefly into it. I'm not going to trace everything here. Guys, I'm gonna graph the, hang on a second here. First, I'm gonna graph the parent sign graph for a reason. What, who is this? And this. Put it in here. Little reminder, parent sign graph had the critical numbers to be these. No problem. And I think it went up to 1, dropped down to a -1. I think it starts at 0, this is sine, guys. Goes up to 1, 0, down to a -1, back to 0, and the graph looks something like this rough sketch here. Something like that. So this is y is equal to sine x. PK, tomorrow in class, I'm in chapter 6 right now. Everybody can now find this. Inverse sign.
Please.
Inverse sign. Please tell me, you had inverses, I think, on the last, I'm talking about inverse trouble on the test. Tell me a little bit about inverses that you remember, and then we'll try to do it on this before the break. Before the break, before we leave. Tell me all you remember about inverse.
Replace x by y.
Replace, I think I said interchange.
Yes.
That's exactly what you do. By the way, now if you interchange right now at this point, I know this is like y is equal to this, or in fact, let's go back to the black one. If I interchange on the black, would you be looking at this? Is that true, guys? I go back to sign and interchange. Like you're supposed to interchange the x and the y, find the inverse. And the second step was to do what? Step 1, interchange. Step 2 was always, and you guys did on the test. What's the second step of the,
Bring.
find the inverse? No, what is it? You solve for y. You interchange and you get y by itself. Now I'm waiting for, closure to the class. This is a good problem, just close class down. Can anyone tell me what is y here? Do it again. Tell me what you think y is, the way it looks like it looks on the board. You gotta solve for y. I interchange, it's supposed to solve for y, only 2 steps to find inverse. Anyone tell me what the y is?
Y squared.
No, you're making it worse. Oh, I heard something else. No, hang on.
Square root x.
Okay. I would say before I take the response, this is the response I have received, I think some students are breaking. Professor, no problem. You want to solve for y, do this to it. And professor, these cancel. And you're left with for an answer, and you go to UCLA and say, oh, I know how to find the inverse sine. What is it? It's x over sine, x over, just SIN. Sine of what? You did it. Oh, you're gonna bring y over here and have, I want y by itself. Well, step 2 is to get the y by itself. Oh yeah, x over sine, or at this point just x over SIN. Ooh. You know it's not that. That's what I get from many students. Just divide by SIN, professor, and get the y by itself. Sine of what? Sine of 45 degrees, sine of pi over 2, you need a theta or an x or something there with it. Not just that, the letters SIN. You can't do that. Now, I'm hearing though, now I haven't done this yet. No, I'm going to do it tomorrow. Professor, you can't do what you just showed us. That makes no sense. What is the best you think I can do?
Well, could you maybe multiply by secant?
Nope.
No.
If I were a student, I'd say the same thing. I probably would say divide by sine, SIN. You can't do that. It's divided by letters, SIN.
If we divide by cosine.
Makes it worse.
Okay.
I got you on this.
I will first define the domain of the sine and the express sine as like a normal parabola function. And then-
Okay, now that domain, we'll consider the domain. We'll say something about the domain involved here. Okay, let me point out what's going to happen here. Guys, you can't get y by itself. Not algebraically. I know some tempting to say divide by sine, do something else to it, and get the y by itself. I can't. All they do is they just go ahead and jot down y is equal to, look at this. Y is equal to inverse sine x. Where inverse doesn't mean you're interchanging. Okay. Now, before we close down today, here's the graph of sine. What's the issue when I come back to class tomorrow, and this is up? What's the issue with me trying to find this in the first place?
It's not one-to-one.
The graph is not one-to-one. And only one-to-one functions have inverses. This thing would not pass the horizontal line test, which is the test for a one-to-one. Guess what the committee, I call the committees, of mathematicians, brilliant people, worldwide, got together, and they said, let's make it one-to-one. Really? Let's make it one-to-one. And guess what they did? We'll close down, I'll finish this up tomorrow. They're gonna make it one-to-one. They suggest, and we have to accept, move out to here, on the left, and your graph down, drop down like this, if you start graphing on the left. You guys agree? And forget I just have that little slice from negative pi over 2 over to a positive pi over 2, just that little slice to work with. By the way, if the committee did that, they cut off the graph, they cut a piece of it off. Is that now one-to-one? Would it pass the horizontal line test? It's one-to-one. They made it one-to-one. Can you imagine putting your fingers on a graphing calculator or a calculator of any sort, and you see that inverse sine key? Oh, by the way, are those inverse sine keys on the keyboard? Of any device that you use to find inverse sine? Is sine with that superscript -1, is that on the keyboard somewhere? Any device you use, is it? It's on there, so it does exist. What they did to make it exist, they did this, they restricted, I guess, the domain. To just negative power two to positive power two. By the way, guys, this thing is now 1-to-1, and tomorrow you'll see more about its inverse. It now has an inverse. There's that restriction. What a blast. June, she works so hard. If she has all this down and those beautiful graphs that she sends to you guys, oh, I appreciate her. But we were busy today. What is today, Monday? Yeah. Monday. Guys, any questions? Okay, now I gave you what, one handout?